Number systems. Specifically, we're looking at all real numbers. Okay, so this is my set of real numbers, and right now there's nothing in there. And so we're going to look at natural numbers first. So natural numbers are the counting numbers, 0, 1, 2, 3, 4, 5, numbers you'd find on your hand. Okay, so let's just say this little circle represents, this little oval represents the natural numbers. Okay, the next set of numbers we have are the integers. The integers are represented by a z, and so it's all from negative infinity all the way up to positive infinity, no decimals. Okay, so the natural numbers are contained inside the integers, okay, which are contained inside the reals. Then we have the rational numbers. Rational numbers are any numbers that can be written as a fraction, okay, such that A, the numerator, is an integer, and B, the denominator, is an integer, just can't be 0, okay? So with 0, we'd have, this would be undefined, all right? And so these are rational numbers. Rational numbers are any number that can be written as a fraction, and the book likes to say that all rationals are repeating decimals. Just sometimes the period, that's the repeating part, is 0. Okay, so 5/13 is a rational number. It is 0.384615, 384615, 384615, and it goes on forever. Okay. Also, non-repeating decimals, terminating decimals, although the book says terminating decimals don't really terminate, they just have 0 as the repeating part. I like that. Groups them all together. So all repeating decimals are rational. Okay, so 3/8 is a repeating decimal. It's 0.3750 repeating. Okay, all right, and then we have irrational numbers. Irrational numbers cannot be written as fractions. Okay, so here's my irrationals. Now notice the reals are made up of rationals and irrationals. The rationals are made up of, you have fractions, and then you have integers, okay, that are not fractions. And then inside the integers, you have the positives, which are called the natural numbers. Okay, so irrationals can't be written as a fraction. Okay, they are non-repeating and non-terminating, but non-repeating decimals. Okay, for example, pi. Pi is 3.1415, and it goes on forever. Okay, and it doesn't repeat. Are there digits that repeat? Sure, there's only 9 digits. So you're going to have digits that show up every so often, but the pattern does not repeat over and over again. Okay, root 2. Root 2 goes on forever as well, like 1.4142135, and it doesn't repeat. Okay, and so on and so forth. So we have the reals are made up of rationals and irrationals. Okay, the natural numbers are contained in the integers. So the natural numbers are a subset of the integers. Okay, natural numbers are a subset of the integers. Is the set of natural numbers is a subset of the integers? I guess you could say that. Natural numbers is a subset of the rationals. Okay, so naturals are a subset. I like R because it's anyhow. The naturals subset of the rationals. And here what I'm saying is 3 is a member of the natural numbers, okay? Or 3 is an element of the natural numbers. 3 is an element of the natural numbers. 3.14, is that pi? No, it's not. This is a rational number because it terminates. It's 3.14, 0 repeating, if you will, okay? So this is a rational. 3.14 is a member of the rationals, okay? Pi is not a member of the rationals. Okay, pi is not an element of the rational numbers, okay, because pi doesn't end. All right, the z with a star means all the positive integers. So like from negative infinity all the way up to -1. Then we skip over to +1, 2, 3, 4, 5, and so on. Okay, so the little star means not 0. Okay, so the star means without a 0. All right, z with a little sub plus means all the positive integers, which are the natural numbers. Notice that, z with a little plus means the naturals. Okay, well that's it. So we have the symbols that you need to know is a subset, so sets can only be subsets. Elements are specific numbers, or specific parts, okay? So if you had if you have a set of clubs, your 9-iron is a member of your set of clubs, right? Okay. All right, so have a good day.